Can you guess the answer for this? Here, a bitwise operator is used, that is a left shift operator. So whenever the bitwise operator comes, the first and foremost thing to be done is to convert the decimal value into binary. Here, the decimal value 3 should be converted into binary, and then the shifting has to be performed in the left hand side twice. Let's look into the explanation. Here, the binary value for 3 is 0, 0, 1, 1 at the LSB, and the remaining bits at the MSB will be zeros. Here totally, we need to perform 2 shifts. During the first shift, the second bit will be moved to the third place and the first bit will be moved to the second place. That is, the bit from second position moved to third position, the bit from first position is moved to second position. After the first shift, the binary value will be 0, 1, 1, 0 at the LSB, and the remaining bits at the MSB will be 0. And during the second shift, bit at the third place is moved to fourth place, and from the second place is moved to third place. So after the second shift, the binary value will be 1, 1, 0, 0 at the LSB. Therefore, the decimal value for 1100 is 12. We can also follow the shortcut, that is given number, that is 3 into 2 power number of shifts. Number of shifts is nothing but 2. So 3 into 2 power 2, that is 3 into 4 will be 12. Let's look into the next question. Here again, a bitwise operator is used, that is a right shift operator, and here the value of 3 should be converted into binary again because it comes with the bitwise operator. Binary value for 3 is 0, 0, 1, 1, and here totally we will do 2 shifts to the right hand side. During the first shift, the bit from the first position will be moved out. It should not be rotated and fixed at the MSB, and the bit from the second place should be moved to the first place. So bit from first position is moved out and bit from second position is moved to the first position. Therefore, after the first shift, the binary value will be 0, 0, 0, 1, and the remaining one which is being removed should not be fixed at the MSB, whereas it should be just ignored. And during the second shift, the bit from the first position will be moved out again, just ignoring it as the previous step. Therefore, after the second shift, the binary value at the position 1 will also be ignored, therefore resulting with the answer 0. And here we have the shortcut, that is given number divided by 2 power number of shifts. The given number is 3 divided by 2 power 2, which is nothing but 0. Because here percentage %d is used as the access specifier, so the answer is 0. If here percentage %f is used as an access specifier, then we'll get the output in some rational number. Let's move into the next question. Here again a bitwise operator is used. So the first and foremost thing that should be done is we need to write down the value for -1, and then shifting should be performed in the left hand side 4 times. So whenever we are writing the binary value for negative numbers, we need to take the 2's complement of its own positive value. So at first, we need to write down the binary value for 1, that is, except the last bit at the LSB, all the bits will be 0. And now we need to take 2's complement. So first we'll do 1's complement, that is, all the 1 will become 0 and the zeros will become 1, that is, except the bit at the LSB, the remaining bits will be 1. And now we need to do the 2's complement by adding 1 to it. Thus the answer will be all the 16 bits will be 1. And now totally we need to do 4 shifts. So we need to consider the first active bit at the MSB. That is, during the first shift, the bit at the 16th place will be moved out, thus adding 0 at the LSB. We should not rotate and fix the bit at the LSB. And during the second shift, again the bit from the 16th place will be moved out, thus adding one more 0 at the LSB. And during this third shift, we'll have 3 zeros added at the LSB, and during the fourth shift, we'll have 4 zeros added at the LSB. Now we need to write the hexadecimal value because we have the format specifier as %x. For 4-1, the hexadecimal value is F, that is 8, 4, 2, 1 will give 15, that is F. So the answer is 4F and 0. What does it mean actually? Can we consider it as an pre-decrement operator? No, because post and pre-decrement and increment operators can be used only to a variable name but not to the values. So here these two minus should be considered as an unary operator. Let's look into the explanation. So unary minus is used twice. So minus into minus will give plus. That is, minus minus 2, we cannot consider it as an pre-decrement operator. So it should be applied only to the variable names like I minus minus or minus minus I. In that case, it should be considered as an unary operator. So minus into minus will be plus, thus resulting with the answer 2. Thank you.